Hello everybody, this is Gigi from Kauai Community College. In this video, we will be talking about the inverse function. Okay, so let's take a look at this example here. We have this green graph there, okay? And if you take a look at the green graph, we know that that is the parent graph, the parent function 2 to the x, right? So you have the point 0, 1, 1, 2, 2, 4, negative 1, 1 half. Okay, that's a parent function, 2 to the x. Now, we define the orange function there to be the inverse of the green. Okay, now what is the inverse? It's the reflection of the function over the line y equals x. So this right here is the line y equals x. Okay, now, so when we look at the reflection, we notice that instead of 0, 1, the new point on the inverse is 1, 0. Instead of 1, 2, the point on the inverse is 2, 1 when we reflected that over the line y equals x. Similarly, the point 2, 4 is now at 4, 2. And then the point negative 1, 1 half is now at 1 half, negative 1. Well, if you think about your parent function, that's the parent function for log base 2 of x, right? And we know that. We know from the definition of log is that it is an inverse operation of exponential, right? And we do that when we solve onion problems, because that's how we undo exponential. We use log, right? Now, but what we want to look at in terms of what happened when we have the inverse graphically, we notice now that the x and the y values got switched in the process of reflecting it over the line y equals x. Okay, so that's something good to notice, so that we can go and find the inverse for other functions, like this one. So the green, we know that that's f of x equal to x squared, right? Now, if we go and reflect the points, 0, 0 going to stay where it's at, 1, 1 going to stay where it's at when you switch. But instead of 2, 4, it will now be 4, 2, right here, okay? And then instead of negative 1, 1, we now have the point 1, negative 1. And then we have 4, negative 2 instead of negative 2, 4. Okay, so we notice here that this inverse is not a function because the top half is square root of x, and then the bottom half is negative square root of x. Okay, so it doesn't pass, the inverse doesn't pass the vertical line test. Now, think about that for a second. If we look at the green, the original function, f of x, the original function, does not pass the horizontal line test. Therefore, the inverse will not pass the vertical line test. So the inverse is not a function. So do you have a need to make the inverse a function? If you do want the inverse to be a function, then you would have to do what we call, let's restrict the domain of the original function. What does that mean to restrict the domain? Well, if we want the inverse to just be one part of it and not 2 halves, then we would have to restrict the domain of f of x to just be from 0 to infinity. Meaning if we just take the right half and not the left half, then our inverse will just be the top half up here and not the bottom half And we have an inverse function being square root of x, right? And we know the domain of this square root of x parent graph is 0 to infinity, right? And that's the reason why. So if we want, sometimes all functions have inverses, but sometimes the inverse is not a function. And we check that by performing the horizontal line test. Because if the function passes the horizontal line test, then the inverse should pass the vertical line test. So that's how we check to make sure to see if our inverse is a function or not. Here we have the function f of x equal to 2 times x minus 1 to the third power plus 4. We already know how to graph by transformation, and it should look like that when we graph. So when we look at the graph of the function f of x, we can say that f of x passes the horizontal line test. Therefore, the inverse of f of x will be a function. And we can use function notation. This is function notation for inverse. That is inverse function. Inverse of x, not x to the negative 1. Okay, that is the notation for an inverse function of f of x. All right, so let's go find it algebraically. We noticed from earlier that the inverse, when we do the reflection, we notice that the x and y get switched. So algebraically, let's go switch x and y. This right here really is y, so now that becomes x. And then the x will become y. And that is how we get the inverse, right? Switch x and y. Now, we don't normally write a function looking like that. So we're going to go ahead and solve for y. Minus 4 divided by 2, and we're going to write that the fancy way. What's the fancy way of dividing by 2? Multiply by 1/2. And then we're going to cube root both sides. And then we are going to add 1. So now, the inverse function, again, this is notation for inverse of x. Okay, and that is now a function. The inverse function is cube root of 1/2 x minus 4 times x minus 4, all that plus 1 at the end. And that's how you find the inverse algebraically. Switch x and y, and then solve for y. So step 1, switch x and y. Step 2, solve for y. And then check. If the inverse is going to be a function, then we use function notation for inverse. Let's find the inverse of that. And I wanted to look at this because it looks kind of complicated. It's not one of those that we could visualize using graphing by transformation. But we still can go find the inverse, right? How do we find the inverse? Switch x and y. So x become y, and then y becomes x. This right here, again, f of x is the same as y, right? All right, so let's go and solve for y, right? So switch x and y, and then solve for y. Multiply to undo division. Multiply both sides by y minus 5. That is gone. And when you distribute here, you will get x y minus 5x equals to y plus 3. We see that y is here on the left-hand side. Is y on the right-hand side? Well, let's go and get y together. Everything else on the other side. And then factor out the y. And then divide both sides by x minus 1. the inverse function is, oh, actually, I couldn't say yet the inverse function. I can say that the inverse of f of x is this. Now, when do I use the inverse of x notation? When I have gone and confirmed that this right here passes the horizontal line test. Does it? We don't know. I don't know how that graph looked like. So let's be safe and just say the inverse is y equals 5x plus 3 over x minus 1. And we confirm or deny that later in the next unit. All right, now suppose you have a graph. How can you find the inverse? Let's review that one more time. The inverse function is when you switch x and y. So we notice here that this function has a horizontal asymptote of y equals 1. So the inverse must have a vertical asymptote at x equal to 1. What about the points? Let's go put in some points here. The points 0, 2 will become 2, 0. The point 1, 4 will become 4, 1. The point 2, 10 will become 10, 2. And we have this graph here in blue. Okay, now we know that the original function, let's call that f of x. F of x passes the horizontal line test. So our inverse is going to pass the vertical line test. So our inverse is a function. And we can call that the inverse function in terms of x. And that is the notation for inverse function. And you notice now that reflection over the y equals x line. Yeah? Switch x and y, that's what happened. And that is how we find the inverse. That's it.